Hi ladies and gentlemen, this is Mr. Green and this is the Class Connect for Geometry for Thursday. Now, I am still giving star tests. I know you think they're all done with this week, but I have to give star tests to a few younger students, so I'm not available for Class Connect today. So I've got this recording for you, okay? I appreciate you guys listening to it. Now, um, I don't believe we're doing a review. You've already finished that. Yeah, we're done with Unit 3, aren't we? I didn't get this changed. I apologize. We're into Unit 4, and we're dealing with arcs and chords and tangents and secants. Okay? And don't forget, I really do appreciate you guys making quiz corrections. It really helps your grade. It gets you to rework the problems. You will make some points out of it, and it is helpful to your grade, okay? Don't forget, 28 days after assignment closes, it locks up. Can't get back into it. You want to get them done, not have zeros in your grade book, okay? So here we go. We're going to start looking at arcs and chords, okay? So let's start with this. AD. AD is something that goes all the way across the circle, like that, right? That is called an arc. I'm sorry, that's called a chord. But since it goes through the center of the circle, that would not only be called a chord, it would be called a diameter. The diameter is a specific type of chord, specific chord. Okay, how about PB? PB goes through the center as well, and it goes out to the edge. Nope, that's simply a radius, no chord at all. Okay, starts at the center or starts at the edge of a circle and goes to the center. That would be simply called a radius. BD. BD goes all the way across the circle, but it doesn't go through the center. That means it's not a chord? Nope, that is a chord. Okay, a chord. But it is not a diameter, is it? It doesn't go through the center, so it is just a chord in that situation. Let's look at angle BPD. See how it's got P in the middle here? That's the name of my circle, isn't it? Circle P. That means it's going through the center of the circle, BPD. It's this angle right here. That is called a central angle. Central angle. Because it's using the vertex is at the center of the circle. Okay? As opposed to angle BDA, that's this angle over here. Okay? It's not centered in the center of the circle. It's got its center out here on the edge of the circle. And it's got chords that go across the circle. That makes this an inscribed angle. Okay? The difference between these is where the center of the angle is located, this vertex. This vertex being on the edge of the circle is called an inscribed angle. The center being in the center of the circle is called a central angle. That's how you can tell them apart. Point P is the center of the circle. Okay? Now a little bit about arcs as well. If I wanted to identify arc AB, A to B like that, I would say AB, and I would put a little arc over it like that, saying that it's arc AB. Okay? But if I didn't mean that arc, I meant the one that went around the circle the other way, the long way around, I would need to use 3 letters to represent that. I would say ACB, because that means I'm going through point C to get to point B. Or I might say a DB. It doesn't matter which one I use there. It just was another point on the circle showing that I'm going the long way around to get to that arc. Okay? So that's the difference in what's called a minor arc and a major arc. Okay? An arc basically has the same measurement as the angle that forms it. So BD here will have the same angle measurement. Arc BD has the same angle measurement as this central angle. And that's the way you can get angle measurements. They're measured in degrees. Let's look at that a little closer. Here we've got EF being a diameter of circle D, and that GDE, this angle right here, is 105 degrees. That's important because GDE is a central angle. It's got its point right there in the center of the circle, right? And they're wanting to know the measure of this arc out here, FG. Well, we've got enough information to do this because the first thing they told us was that EF was a diameter. That means that arc EGF is 180 degrees. And that arc EG, which is made by the central angle, is 105 degrees. And so we can actually find GF, arc GF, by simply subtracting 180 minus 105, and we'll find out that that's 75 degrees. Okay? I called it GF, they called it FG. It's the same arc. Okay. Here we've got a little bit more complicated circle. They're saying if angle GDF is 55 degrees, that's this one here, they're asking what's the measure of EH? EH is way over here. How are these related, Mr. Green? Well, you see this little double line right there? That's telling you that those two chords are the same length. And so since this angle was 55, this arc was 55, and since these chords are equal, the arcs are going to be equal too. Okay? So what is the measure of arc EH? 55 degrees. Okay? They're telling you that angle CDE, let's see here, where's CDE? CDE is 120 degrees, and they're wanting to know the measurement of arc EGC. Well, really this is not hard because this is 120. That makes this angle in here 60 degrees, right? If this one's 60 degrees, this arc there is 60 degrees, and from E to F is 180. So I'm going to say 180 plus 60 is equal to 240 degrees. That really wasn't that difficult a process to go through to get there, was it? Okay? For part C here, they're changing a couple of measurements on me. They're saying that the measurement of arc EH is 43 degrees. Right there. Since this chord's the same length as this one, that makes this chord 43 degrees, or this arc 43 degrees, and that makes this angle 43 degrees. And that's what they were asking about here, was what's the measure of that angle? 43 degrees. The trick there is to know if the chords are equal, then the arcs are equal. Angles are actually form the chords, and the arcs will then be equal as well. Cool. Okay, now I'm going to slip into tangents. Tangents are a line that goes through the circle at only one point. It touches it at that one single point right there. Okay? Now, one thing about tangents, if I have a radius of the circle and a tangent at the same point, it makes a 90-degree angle. So having said that, if you just look at this problem and you look at it and say, wait a second, it's asking me about this triangle right here. And we've studied triangles in the past. So this is nothing more than a triangle problem with a circle drawn around it, right? And they're asking me what's the measurement of this angle right in here. Well, we know that measurement's going to be 180 minus 90 plus 65. And that's what that angle is going to be. Okay? It's going to be, what, 25? Yeah, 25 degrees. Okay? Okay. Looking at this one, they're asking what's the measurement of BE, this chord going all the way across there. Well, this chord actually makes a 90-degree angle with the radius, doesn't it? Well, when it does that, it means that the chord is actually divided in half. So if this one's 6, this one's 6, and 6 plus 6 gives you 12. That was meant to throw in as an easy one. All we had to do was add those two together. Okay? Looking at this one, they're saying AD is a radius, and they're giving me these two angle measurements. Well, if I add those together, 62 plus 33, I get 95. That means that this angle right here must be an 85-degree measurement, because it's a triangle, right? It's not 90, is it? That means we don't know anything about this chord EC. So we don't know that this one will be equal to this one. And as a matter of fact, we would say they're not equal because not at a right angle with radius. If it's not at a right angle with the radius, it's not going to be, they're not going to be bisected. Okay? Looking at this one, well, we got 20 and 70. That means that this is a 90-degree angle right there. Right? If that's 90, then this one over here is 90. Guess what? I know that this side is the same on these two triangles, and I know that this one is being bisected because it's a chord, and it makes a 90-degree angle with a radius. So if I've got side, angle, side, and side, angle, side, I can say that small triangle is congruent to the small triangle over here, since I can write that down. Triangle BEA is similar to triangle to CEA. Since those two triangles are similar, then I would say that the angle A, I'm sorry, DAC is equal to or congruent to angle DAB. And since they're both central angles, the arcs made by them will be equal. Arcs BD will be congruent to arc DC, and that means the chords underneath them, BD, will be congruent to DC. That's how you can get there. Okay? I got there by first of all proving triangles congruent. After I proved the triangles were congruent, I said, well, the angles are congruent because they're corresponding angles. And since they're central angles, that means the arcs are congruent. And since the arcs are congruent, that means that the chords that make them are congruent too. See how we're going back to those proofs again? Okay? So what we're doing here is we're working with what are called sectors and arcs and things like that. It's all a part of these teaks right here. We're going to get more into these as we go along in the next couple of weeks. Okay? So I hope that helps. My secret word for today, treehouse. So you watch this video, send me a K-mail telling me that you're in geometry and what course, what section number of geometry that you're in, and that your secret word for today was treehouse. And I'll give you credit for having watched this, and have a good week, and I'll see you next week.